All right, welcome back. Today we're going to be starting lesson 2 in our unit 5 workbook, and this starts on page 8. And we're going to be extending some of our discussion into the mobiles and the equations tied to the mobiles. So again, we are on page 8 here. Okay, so Miley and Ben and Amina were solving this mobile and it's matching equations. So we've got this equation here, 9 plus 3c. So it looks like they put a 9 here and 3 circles equals 10 plus c plus 7. So this mobile balances here. They started in 3 different ways and all found the same correct solution. Okay. So over here it says when solving an equation, the only steps that make sense are ones that would keep the matching mobile balanced. So meaning the only thing we can do would have the mobile balanced on the side at the same time. So here it says, Miley, change the equation. 9 plus 3c equals 10 plus c plus 7 into 3c equals 1 plus c plus 7. Circle the mobile that best matches the new equation. So it looks like she kept 3c here, so she got rid of 9. So it looks like she subtracted 9 on both sides. Which here, if you take 9 away from 10, you have 1 left over. Here they just canceled c's, which didn't happen here. And here they combined like terms, which we didn't do here. So B is the correct answer in this case. Ben crossed out matching circles on his mobile. Circle the equation that best shows this change. Okay, so he got rid of a circle on each side. So you still have 9 here. So these two have 9. This one has 2c, this one has 3c, but we see that Ben now only has 2 circles here and 10 and 7. So this equation matches what the mobile has. Amina also changed the mobile. Circle the equation that describes the result of this change. So they combined like terms here. So they have 9 plus 3c. So 9 plus 3c equals c plus 17. So D is that answer right there. So just matching the mobile here to the equation. Okay, number 4 says 4 of the following changes will keep this mobile balanced. Cross out the one that won't keep it balanced. So we have this here, this mobile that is currently balanced. And then one of these will not keep it balanced. So if I subtract an S from both sides, okay, I got a star and a star. If I cancel those out, it still stays balanced. Subtracting 9 from both sides. Here's your key word. If you're doing it from both sides, it's going to stay balanced. So if I subtract 9 here and cancel 9 here, it's going to stay balanced. Combine the 12 and the 27, so the right side becomes 39 plus S. So 7, 8, 9. So this together does equal 39, and I can combine it on the same side. So this is true. Move all the stars to the left and all the numbers to the right and get 5S plus or equals 48. Now you can move all the stars to the left and all the numbers to the right, but it's not adding. Okay, if I take this and move it from the right to the left, I don't add it over here. I have to subtract it from this side and subtract it from that side. Okay, so we can't just move them without changing something. So this one does not work at all. Rearrange the left side to get 4S plus 9. So I do have 4S plus 9 equals 12 plus 27. So that is true. They're just rearranging the numbers a bit. Okay, this algebraic habits of mind. Okay, visualizations are often helpful tools for organizing and thinking through mathematical ideas. Mobiles are useful for thinking about balance and can serve as a metaphor when thinking of equations. Drawing mobiles is not always useful. For example, it would not be efficient to draw a seventh of a star or 1/7 s or negative 6.28 circles for negative 6.28 c. But every equation balances, so you can think of the mobiles and consider what moves preserve equality. Okay. So kind of like here, they've got bubbles with numbers in them. You can do that with decimals and those kind of things to kind of help you out. But again, mobiles are useful, but not necessarily the best use in every situation. Okay, 3 of these mobiles can be made from the equation 7 plus f plus 8 equals 3f plus 5. Cross out the one that cannot. Okay, so here we have 7 plus a flower plus 8, 3f plus 5. So this one's good. Okay, here we have 3 plus 5, which is this side, and 15 plus f. So 8 plus 7 is 15, so that's fine. And then just flip-flop the sides. 15 and 5, well, here they just moved all the flowers to one side and all the number. You can't do that. 15, 5, and it looks like they just marked out a flower on each side, which you can do that. Number 6, this mobile balances. Cross out the 2 equations that can't be made from this mobile. Okay, so you got 6, a p, 6p9 equals 11 and 3p. So this one's good. 15, so 6 plus 9, 15 equals p plus 11 plus, so they just added this to the other side and you cannot do that. 6 plus 9 equals 11 plus 2, so they marked out one of the pentagons. 15 plus 11 plus 2p, so again they combined these like terms and crossed out a pentagon. 15 plus 11 plus 3p, so they just got rid of this one but still had 3 over here, so that cannot happen. Draw a mobile that matches this equation. Okay, so 2c, so we're going to put 2 circles plus 5, so we'll put a circle with the number 5 in there. We'll color these in. Plus c, so another little circle. 3 circle 4. Okay, so that represents that equation. Write 2 new equations that must be true for this equation. Well, if I combine like terms on each side, so I have 3 circles plus 5 equals 7 plus a circle. Okay, that could work. And then I could leave this and I could just cross out a circle on each side. So 2 circle plus 5 equals 7, because I crossed that out. And then this right here equals 7. Okay, so this also works as well. And we're on our way to solving some of these multi-step equations here. Okay, so solve the mobile puzzle, keeping track of your steps. Perform the same steps on the equation, solve for t, and check your solutions to match. Okay, so we're going to solve this and show our work over here on the mobile. Okay, so if I first, let's just cross out a couple of these t's, or these triangles here. So if I cross this one out and I cross this one out, okay, so that's crossing this one and this one. and this one, and one of those. So I have 11. Well, we can do it one at a time. So I cross out this one. So I have 11 plus t equals t plus 5 plus t. And then we cross out this last one. So this one and this one. 11 equals t plus 5. And now I need to cancel my numbers. Okay, so 5 away from here. So 11 minus 5 would be 6. So I get rid of this one, I get rid of this one, I get 6. So t equals 6 over here. And a triangle, which is what I have left over here, is equal to 6. Okay, so they match. Draw a mobile that matches the equation and solve both the mobile puzzle and the equation. Okay, so I have a heart, 5, and then 2 hearts, 13, and a heart. Okay, so the first thing I'm going to do is mark out this heart. Okay, so I have 5 plus 2h equals 13. Okay, then I'm going to get rid of this 5 and get rid of 5 from here. So 13 minus 5 is 8. So I got rid of the 5. So 2h equals 8. And if 2 hearts equals 8, okay, then if I divide 8 in half, that means a heart equals 4. Okay? So a heart here is 4, and a heart here is also 4 because we divided in half. You have 2 hearts equals 8. Number 11, 3 of the following steps make sense if you are solving this equation. Cross out the 2 that won't keep the equation true. Okay, so on the right side, turn 2b plus b into 3b. So I can combine this if it's on the same side, in which it is right here. So that one's good. Subtract 2 from both sides. I can subtract 2 from both sides. So that one's good. We'll just put a little check here if it checks out. Subtract 3b from both sides. Yep, I could do that. Even if 3b wasn't in here, you could still subtract the same thing or add the same thing to both sides. Combine all the b's and all the numbers to get 8b equals 18. And you cannot just combine everything and pick what side it goes on. Subtract b from the right and add it to the left side. You cannot do that. If you subtract it from the right, you have to subtract it from the left as well. What is the value of f in problem 5? Okay, so we're going up here to problem 5, and we can use any one of these to help us. I'm going to use this one because it has the least number of flowers. Okay, so if I cancel, I got 5 over here and 15 over here. If I get rid of these 5, I have to get rid of 5 over here. So now I have 10 left over. If 10 equals 2 flowers, then 1 flower would just equal 5. So f is 5. What is the value of p in problem 6? Okay, so here's problem 6. And we know that this and this equals 15. I can cancel these 2. Okay, so now I'm kind of at this equation right here. If I get rid of 11 over here, I got to get rid of 11 over here. So I'm left with 4. And 4 equals 2 of these pentagons. So to get 1 pentagon, I just divide it in half. And I will get p equals 2. Okay. So that is all that we have for this first part of the lesson. Okay, mobiles versus equations. They are the exact same thing. So you can actually use a mobile to help you solve an equation. The next lesson, we're going to go through page 10 and kind of some of the harder stuff, but you can definitely go ahead and get started on page 11 so that you're ready for the quiz when it comes out. Okay, if you have any questions, feel free to let me know. Thanks for watching, and I will see you in the next lesson.